Hello student, today we are going to start class 9 subject physics, and first we discuss the whole syllabus. So as we see that the first chapter we have to study about the motions, the second chapter the force and laws of motions, the third chapter is gravitation, the fourth chapter work and energy, and the fifth chapter is sound. Especially for competitive students, these 5 chapters of the class 9 is very important for any competitions exam, because there are so many good concepts about these chapters that will be provided in class 9, as well as there are lots of numerical problems that are frequently come in the different type of competitive exams. So we will start with the first chapter, that is now we understand about the concept of motion. And firstly we understand that what is motions. So basically any moving bodies, if we consider any moving bodies that have a common characteristics, and what is that common characteristic? That is they changing their position with respect to time. So this is the basic common characteristics of any moving bodies. So in this way we can define that motion. How can we define the motions with respect to any systems or any object? So the motion is defined as, we can say that an object is said to be in motion when it changes their position with respect to time. So here we try to understand that the motion of an object have two factors, that is position and time. That means any moving body have the characteristic of changing their positions with respect to time. We take an example to understand that how any object is said to be in motion. So first we consider this is a person t equal to 0 second, the point A. Now this person is moving, and now t equal to 5 second at point B, and this person again moves to point C at t equal to 10 second. So in the whole phenomena, what happens? This person at t equal to 0 second, when these persons considered at point A, these are in rest, because at that point of time they are not changing their position with respect to time. But now when we take a reference time of 0 seconds, then it will moving from point A to point C in how much time interval? In 10 seconds. So here we can see that when the time will increase, when the time will change, its positions will also change. So we can say in this reference that this man, this is considered, this is Ram. So Ram is in motion for 10 seconds. When it changes their positions from A to B to C. So basically what happens? So in this case we can see that a ramp is changing their position with respect to time, and at point C, if there is no movement, there is no position change at point C, from the point C to the rest of time, it is considered in the rest, because at point C they are further, they are not moving, they are not changing their position with respect to time. So one terms, in this way, one terms we can also define the rest. So similarly, the rest, what is rest? It means an object is said to be in rest when it does not change their position with respect to time. So how can we define the motion? An object is said to be in motion when it changes their position with respect to time, as well as how can we define the rest? An object is said to be in rest when it does not change their position with respect to time. Here we studied a new concept about motion, that motion is a relative terms. So what does it mean that it is a relative terms? So when we define that motion of an object is considered when it changes their position with respect to time. So basically we always define a position in relation to the time. So there are two terms that will be relative to each other. We always define with the one quantity or one things with the other things. So basically here the motion can be considered not only with respect to time if the object will change their positions. In real situations, sometimes we can also consider, or we can also evaluate that an object is said to be in motions with respect to some frame of reference. Here the frame of reference means some stationary objects, and we can consider that any object is moving or not moving with reference to that static frame of reference, or with that static systems, or with that static bodies. So that's why motion is considered as a relative terms, because sometimes we can define the motions about the motions in terms of the positions with respect to time, or in terms of the changing the positions with respect to time, as well as sometimes motion can be defined with respect to some static frame of reference, some static systems, or some static bodies. Here we take an example and try to understand that how the motion is a relative terms, and how the motions we can define in terms of some static frame of reference. So consider this is a bus stop, and here a person is standing. Consider this is a bus, point A. Now this is point B. Point C. In these buses there are lots of seats, but we consider that two persons are sitting in front of each other. So here so firstly we see this example with respect to time, that how the bus will changing their position with respect to time. So consider that at t equal to 0 second, it is a point A, Now t equal to 10 seconds, it is at point B where the bus stops, and now at point C it is t equal to 20 seconds. Now, so if we see this bus that will be moving continuously from point A to point C with respect to time, that means this bus are in motion from point A to point C. Now, what is the importance of these bus stops or these persons that are standing on the bus stops? So, these bus stops or these persons that are standing on the bus stops is considered as a static frame of reference. And when these persons are looking this bus, so they are looking that their positions will continuously changing. These bus are moving towards them, and now these bus are at point C. When the bus are moving toward the point C, this person looking that this bus have changing their positions and they are moving away from the bus stops or away from them. So in this way, if they are not looking the time or they are not considered the time, they are not considered the changing the position with relation to time, but they are able to say that this bus is in motion. How they are able to say, how he is able to say that these bus are in motion? So basically these buses changing their positions, and they are changing their positions compared to these static frame of reference. They are considered, they are relate with themselves that we are stationary objects, and the bus will continuously changing with respect to them. So in this way we can say that the motions is a relative terms, because we can define that if an object will change their positions with respect to some static frame of reference also, then that object will also considered is in motions, right? In another example, we can look at that the two persons sitting in the bus, these two persons that are inside in the bus, they are moving, and basically when the bus is moving, these are also moving. But if these two persons are relate with them and relate with each other, then these persons are not considered as in motion, because these are sitting at a simply they are sitting at a fixed place, and they are not moving with each other. They are not changing their position with respect to time or with respect to each other. So, but these persons are considered in motion with respect to these persons, this static frame of reference, because when the bus will move towards them and then away from them, so basically this person looks that this person had changing their positions with respect to this static frame of reference. So these persons, these two persons are in motion. These two persons are in motion with reference to this static frame of reference, but these two persons does not in motion with reference to their positions or with reference to each other, right? So what do we understand from these examples? That the motion is a relative term. Motion is purely a relative terms. The motion can be relate the any object, the changing the any object that will be change their positions, and that changing positions can relate with a time as well as some static frame of reference. So finally, how can we define the motions? That motion of an object is defined when that object will change their positions with respect to time as well as some static frame of reference, right? So try to understand that motion is a relative term. So motion can be related with the time as well as some static frame of reference. And what can be related? The changing in the positions of the object can relate with the time as well as some static frame of reference. In this way, we can say that motion is a relative terms.